We're going to find the derivative of the cosine curve. First of all, let's backtrack and have a look at the circle. Unit circle, radius is 1. Any point on the circle can be called x over and y up. Adjacent over hypotenuse is cosine, okay? And opposite over hypotenuse is called sine, okay? Now we have to get the numbers on the circle. So at 0, it's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. 0, 90 is pi by 2, 180 is pi, 270 is 390s, and 2 pi, or 360. We're going to do the cosine curve. It's first. It starts at 1. Okay, cos starts at 1. Let's call this 1. This is negative 1. Starts at 1. Cos goes to 0. Goes to negative 1. Okay, goes back to 0. And it goes back to 1. I'm going to sketch it with a dotted line. Remember, I'm doing this because it's easier for me to sketch. It looks something like this. And that is y is cos x. We want to find what is the derivative of cos x. Okay, so now I'm looking for the slopes. Where is the slope 0? Here, here, and here. The slope is 0 at the origin. Okay, it's 0 at pi. Okay, and it's 0 at 2 pi. Okay, and at pi by 2 over here, and 3 pi by 2, pi by 2, and 3 pi by 2. So we know where the zeros are. 1, 2, and 3. Well, between these two zeros, okay, it's 0, it's negative, and then it's 0. Okay? So over here, it's negative all the way over to here. So it goes like this. Okay? And from here, wherever it's 0, then back to 0, it's going to be all positive. So it's going to go this way, like this, and like that. Okay, so if you really look at it, this looks like the sine curve upside down, which makes this looks like minus sine theta. Okay, remember, the sine curve, notice the cosine starts at 0, goes to 1, goes to 0, goes to minus 1, goes to 0. It looks like this. Okay, so this is the sine curve. And this here is the minus sine curve. So therefore, the derivative of the cos function is negative sine. If it starts in C, it will be negative.